Ich sag einfach, danke, ich bin Wolle, also du kannst nur dich vorstellen.
So, I've heard you can already hear us, so let's kick things off. Thanks for being here and thanks for having us here. So we're going to talk about web performance and speed optimization monitoring, all these kind of things. I'm Sebastian, conversion specialist at Google. So I basically consult companies on getting more out of their traffic, like better conversion rates, lower bounce rates. And that includes performance, as you can tell. And we're going to talk about exactly that today. And my sincere hope is that you go out later today after the session telling this was a good session, but that guy from Google, I didn't learn shit from him. And I tell that, and I say you that because I'm going to set the scene. And I hope the scene that I'm going to set is one that you're very, very familiar with. So hopefully nothing new in my content, tons of exciting stuff in Wolle's content. So let's find out. First of all, again, it's about measure user experience on the web. And first of all, I want to give you the why, then I want to give you the the what, and then the how. So let's start with the why. Like, why should you care? And this is what we usually talk to your business colleagues. So it's basically, there is a direct correlation, and that has been proven and that has been measured between business success and website performance and loading speed. So there's a case study called Milliseconds Make Million. It stems back from, I want to say, a year ago. So again, old news from me, where we basically Deloitte tried to actually prove to what degree a faster loading website can have an impact on conversion rate. And it's safe to say that there is a direct correlation. To give you a couple of numbers, basically 0.1 or 1 millisecond faster loading speed on average led to 8% increase in conversion rate on e-commerce website, 11% uplift on travel websites, just to give you two examples. So this is basically one direct correlation and one direct impact and one direct reason why you should care. There are a couple of indirect ones. One being, and this is basically why this entire topic, at least from our perspective, gained so much in popularity, is we introduced, again, old news, more than a year ago, we introduced basically these performance measures being an impact factor on basically your organic ranking signals, if you will. So basically, there's a ranking factor called page experience, and this is to a certain degree fed by these performance KPIs. So another reason to care about, because indirectly it will impact your business. Another one is basically your paid marketing colleagues will thank you quite a bit because there's something called the paid ads quality score. You may have heard of it, impacted by the landing page speed score, which then again, you've guessed it, is also impacted by this information. And something that we're looking into at the moment quite heavily, also indirect, but quite important and quite zeitgeisty, if you will, is that faster loading websites consume less energy, therefore carbon footprints are better. So also something to do, also important if you want to do something for the environment, to really care about these kind of things. Which is why we focus, like we at Google really, really deeply care about performance measurement, and which is why we, together with others, introduced the Core Web Vitals a couple of years ago. Why did we do so? Because you may have known there's a plethora of KPIs that you could look at, like tons of KPIs that measure speed or stability to a certain degree. And there was little to no agreement within industries and among players what are the most important KPIs to look at. So what we did, together with others again, we actually tried to condense this variety of KPIs and say, let's find out if there's a small subset that is clearly customer-centric, that doesn't necessarily answer the questions that you, as the developers, engineers, product owners, business people have, but that answers questions that your customers might have. And this is basically where these Core Web Vitals came from. And we basically narrowed it down to 3. A fourth one is currently in discussion and in testing. But as of today, September 2022, we talk about 3 Core Web Vitals KPIs, answering 3 vital questions that customers have. And those questions are, if you enter a website for the very first time, so you hit the link that redirects you to the website, you might occur, and you could look in yourself and see if that's the same with you. You might answer yourself or ask yourself 3 questions. First of all, is anything happening at all? Like, why do I have to stare at that blank screen? Like, what's going on? Second question is, once things are happening, is that link that I'm seeing, is this already interactive? And the last question that people might ask is the site done loading? Does it run stable right now? And the KPIs answer exactly those questions. So there are 3 KPIs in existence at the moment. Largest contentful paint to answer the question, is anything happening at all? First input delay to answer the question on, do links work? Like, is the site interactive? And last but not least, the cumulative layout shift to answer the question, does the site run stable? Which equals, is it done loading? LCS measures basically the largest contentful paint, like how much time does it take for the largest element in the viewport to be rendered. Large does not mean as in weight, like how many kilobytes, but basically stuff that covers the biggest portion of the website. Hypothesis here is basically, if I see the biggest image or the biggest piece of text or headline or whatever is your largest element, the user already knows what this website is going to be about, and he already might know, is it worth staying, or is it worth waiting, or should I drop off? It's measured in seconds, if you will. So basically everything below 2.5 seconds is great. Everything, I think, above 4 seconds is not so great. So try to be below 2.5, and no disadvantages for you with regards to usability, SEO ranking, paid search performance, and whatnot. First input delay, also measured in milliseconds. It's the time it takes for an interaction element to be rendered until it is actually functional. So everything below 0.1 seconds is great. Everything above, not so much. Most companies do not have an issue here, which is why let's don't spend much time on this as well. So I would expect most of the websites represented in this room also not really having an issue about that. And last but not least, cumulative layout shift is one that's basically given out as a score, so which makes it a little bit more tricky. And what this does is basically it measures how much of your website's content is moving around because other content is loaded in, and then basically leads to shifts in everything that's rendered on site. That's the only KPI that's basically measured on session. Everything else is measured on load. So which is why if you look at lab tools, and we come to that in a bit, don't trust these CLS numbers in lab tools. Look at field tools, which is what basically the second portion of this talk is going to be about. So pay attention to that, because that's the tricky one, because you cannot really assess it in the lab. You have to really use like live user data in order to be able to say CLS is good or bad. And CLS usually is bad, which is why I'm putting so much focus here, because this is the one where most companies have issues with. This is basically the what you should measure. And now I want to give you some insights about how we at Google measure these kind of KPIs, what we have to offer, give you some advantages, some disadvantages, and using the disadvantages to hand over to Wolle, who will give you a solution for those. So basically, there are 2 types of data that you can assess. One's lab data, the other's field data. Lab data, hence the name, in a simulated area, you basically on a mediocre internet connection, on a mediocre phone, you can basically measure the speed of your website in a hopefully clean environment. Sorry, that was my bad. Field data, on the other hand, this is actual user data. So this is basically something that we provide for every website where it's available, and you can basically check it out. Comes with some advantages, i.e. it's real user data. Some disadvantages, come to that in a bit. Usually what we recommend is, and this is something where Wolle hopefully disagree in his part, it's basically use lab data for your debugging and field data to see what's the impact on your users. And basically what I am going to do now is give you a little bit of a taxonomy on basically what are the data sources that we're having at Google for lab and for field. Lab, for us, it's mainly fed by our Lighthouse API. So as you can see here, we've got the Lighthouse engine, we've got the Chrome user statistics. Lighthouse is all lab. So Lighthouse, basically, you hit a button, that gets measured. So that's a snapshot of that very moment of your own single session. This is basically what you get from Lighthouse. And you see by those arrows and by those representations, basically what tools so no third-party tools, only Google tools, what we have in stock for you to assess that data. Field data, it's mainly feeded by our Chrome usage statistics is then get processed, and then we do have a couple of ways for you to assess that data, and one of which is being the Chrome User Experience Report. And I want to spend a little bit of time to tell you a little bit about how this works in general. So first of all, you may have seen it. If you open up Chrome for the very first time on a new device, you will be asked, do you want to help improve the internet? And if you hit yes, then that's what you do, by allowing basically Chrome to gather data for each website that you're visiting. And we only want to know about what browser are you using, what's your data connection, how fast does the website load. So that data has been gathered. In the next step, we do anonymize that data. We filter out websites where we don't have sufficient data. So we do need a certain amount of data in order to provide that information to you or others, because otherwise it can be coincidental what you see. So we want to be sure that it represents a live view of what's going out there with your users and with other companies' users. And this is then fed to different tools. For instance, the Chrome User Experience Report, which is basically rendered in Google's very own Data Studio. We send it to BigQuery, we send it to PageSpeed Insights. So all these tools that you can use to assess either your own data or any other company's data. So, and that's the beauty of it. So it allows for monitoring your competition. One of the disadvantages is, I said it before, it's basically you need a certain threshold on URL level to see the data for a single URL. Another disadvantage is, and I want to close with that, sort of. Another disadvantage is that since this has to be measured retrospective, it's only updated once a month. So you can either pull it for the rolling 28 days or on a monthly basis for the past 12 months. And why am I saying this? Because this means that this does not allow for debugging and for optimization, because you cannot just run an optimization, pull your field data again, and expect to see the results in there. You need to have to wait at least a month in order to see if what you try to achieve actually worked out. Just to close with an example, so basically, we've got a ton of those, but I just really want to make sure that you care. Like one example from Vodafone, who ran a project about exactly that last year. And as you can see, the business results look quite impressive. So as said, there's unfortunately no way with Google tools to use field data for debugging and for optimization. Other companies have those solutions in stock. And I'll hand over to Wolle now to tell you exactly about what you can do in order basically to use field data for your optimization, for your debugging, to make your website faster and improve it, and even run A/B testing. Wolle.
Yeah, thanks, Sebastian. And hi, everybody. So I'm Wolle from the University of Oldenburg, but today I'm actually here to present backend stuff, because I've also been part of backend for what feels like 1,000 years. And I was head of data engineering and research until recently, and was actively engaged in the development of backend's real user monitoring solution. And that's what we'll be covering in the second part of this talk. So just as a bit of background, Backend is a company that accelerates the web, and that's basically why we are interested in web performance. So yeah, the company basically came into existence as a research spin-off of the Databases and Information Systems group at the University of Hamburg. And then the founders and I as well studied at the university. The company was founded, and a bunch of people, including myself, did their PhD in the company's context. And we also still, until today, have loads of student bachelor's, master's theses in that context, lots of research papers. So we're really actively researching web performance and caching. And all that research is basically baked into SpeedKit, which is a performance plugin to accelerate websites, especially in e-commerce. And it's yeah, growing in adoption. We have thousands of customers there. The revenue that is being accelerated with SpeedKit is quite some revenue. And I think the current numbers are well below above 100 million users every month, and something like 750 million of page impressions that are being tracked every month. So we really see some data from real users here. And the principle of that technology, so basically what the real user monitoring does, is it captures data from the browser's performance timing API. Then we gather all information from the service worker running in the browser, which is basically the core piece of SpeedKit as the acceleration technology. And then we also track errors and that kind of stuff to basically get insights on the web performance and get to know how we can optimize SpeedKit and what the performance on the website is in general. And there are dozens of attributes that we actually have in our database and in the tracking, but you can group them into 3 groups roughly. The first one obviously being performance metrics, so server response time, paint timers, first input delay, basically the metrics that Sebastian went through just now. Then also user engagement metrics like the session length, the time that users spent on site, bounce rates, and the likes, and also debugging or quality assurance metadata like distribution of browsers and devices, caching insights, info on JavaScript errors, and things like that. And if we drill a bit into detail here, what happens is basically that JavaScript code in all browsers, so not just Chrome, but any browser, collects data and then sends that off to some cloud backend. There we store the raw tracking information and then do processing on that. And the first system that we had at backend was batch-based, which stuck pretty hard as it turned out. So we rebuilt that with a continuous system, which is based on Flink, and we'll talk about that in a few minutes. And then we connected all the aggregated and basically processed data to all kinds of systems for dashboarding, alerting, data warehousing for debugging and things like that. And before we talk about the actual analysis and the dashboarding part, let's look at what the data pipeline looks like and why it is so special. So the pipeline at backend basically is twofold. So people using the website with SpeedKit obviously leave traces, for example, in the access logs of the infrastructure below. And that's mainly content delivery network logs in Fastly, which is the main CDN that is used by SpeedKit. And then also we send the real user monitoring data away actively, which is the stuff that we're focusing in this talk. So you can ignore the other data portions for now. And then the data is received by the cloud backend, which was batch-based at the beginning, as I said, but then we rebuilt it in continuous fashion because it turned out that for debugging and basically the things that Sebastian just mentioned can't be done with CrUX. We need very low latency from things happening on the website until we can analyze them in the dashboard. And that's why we rebuild everything in continuous fashion. And that's basically the fast path that you see at the bottom right there. But we also retain the batch-based part of the system so that we can do complex analyses with a little more delay, but basically arbitrarily complex analyses. And yeah, this architecture here, there are talks on this specific thing, is based on Flink and Elasticsearch and Kibana right now. And yeah, if you're interested, check out other talks on that topic or our research paper. Yeah, now basically we have low latency data coming into our dashboards, and why this is important is explained on this slide, because SpeedKit is a technology for accelerating websites. So you might think it's like a CDN, but it's not like a CDN. And that's a pretty big difference because SpeedKit is browser-based. And that means you can disable and enable it for individual users. And this is something that you can't do with traditional CDNs, because you either enable the CDN and all the traffic goes through it, or you disable it and the traffic doesn't go through it. And since SpeedKit can just be enabled for a portion of the users, what backend does is it enables it for, say, half of all users, and then collects data from all the users at the same time. And this is awesome because you have a statistically clean A/B setup here and can just compare over the same time frame. For example, does SpeedKit actually make things load faster? And does that have an impact on, say, user behavior? For example, do people click more? Do they bounce less often? Things like that. And that's what is being done with the dashboarding analytics engine that is used at backend. And to make this super fast and real time, we decided to not build this on the raw data, so all the dashboarding doesn't really query the incoming, the raw page impressions, but we rather pre-aggregate everything by dimensions that we decide upon at the beginning. So for example, browser and device type and the test group, so whether people are actually accelerated by SpeedKit or not. And after every full minute, we write summary data grouped by those dimensions into an intermediate storage, which is Elasticsearch. And as you can see here, we also summarize attributes. For example, performance timers are written as histograms. And for example, Boolean flags would be translated to counters and things like that. And the beauty of this approach is that when you have, for example, here you see 1105 and 1106, there are different summaries for all kinds of groupings. If you now want to render something in the dashboard, say for a time frame, for example, 1106.05 until 1106, your dashboard query just has to touch very few summary records in the intermediate storage. And it doesn't really matter how many traffic was in those groups, because the number of raw data records that you would have to touch to compute this for a very large customer would be gigantic. And for a small customer, it's pretty easy. And this three-level aggregation approach makes dashboarding pretty efficient. Yeah, blah, blah. That was basically the technical stuff, how we aggregate data. I think the part where we really draw the connection to CrUX is here, because this is basically what we want in our dashboard. So you see it looks a bit CrUXy. We have stuff that you also know from Google, like the traffic performance light at the top right, and you have bar charts with performance numbers. And the thing that really differentiates it optically from a CrUX report is that you have basically everything 2 times, because you see performance of the original website and the accelerated website version using SpeedKit. And now what you can do in a real user monitoring dashboard, like the one that Backend has built, is you can filter by different dimensions. So now, for example, we could be looking at all users for a given website. And when we say, okay, we're only interested in Chrome users, things may be different a bit. And then we can say, okay, maybe we're analyzing performance for category pages or product pages or landing pages or whatever. Then we could also use custom dimensions to filter this down. And this is something that is special compared with CrUX, because, for example, you wouldn't have product pages as a dimension value in your CrUX report because it's specific to your website. But this is basically something that is cool with RUM. But let's zoom out a bit again, because when you're talking about Chrome performance, something that is very intuitive is basically you check the RUM data, you look in your dashboard and say, okay, this is the performance. Now let's check the CrUX report. And then you may get something like this, where the CrUX report says, yeah, performance overall is somewhere in the middle between both test groups. And you're like, oh yeah, well, looks reasonable, why not? But sometimes you also could get something like this, where CrUX says, okay, overall performance is worse than both test groups. And you would go like, huh? Why is that? You know, that sounds a bit strange. Could also be that CrUX says performance is significantly better than both test groups. But anyways, you would say, okay, this doesn't really line up. So why is that? CrUX says something that doesn't really align with RUM data. What's correct now? And the surprising answer, which is basically what is hinted at in the title, is probably both. Yeah, what? Why is that? I mean, you have CrUX data, Google is doing things correctly, I assume, but you build your own RUM pipeline, or you're using a tool by someone who you trust, and they also seem smart, so how can that be? To understand what's happening here, let's talk about what CrUX data actually is. So basically, CrUX data, and that's what everybody says, is, yeah, it's performance data from Chrome users. And this is a filter that you can easily rebuild in your RUM solution, because, yeah, I mean, you can just filter down to Chrome users, and then you get the performance from all the Chrome users. But the thing is, CrUX, for all kinds of reasons, doesn't give you the performance of all CrUX Chrome users, but only from some of them, namely the ones that, I can't read the thing here, basically sync their browser history without a passphrase, and who are logged into their account, and who also basically actively opted into the statistics usage thingy that Sebastian mentioned in the beginning. And the thing is that you can filter down to Chrome users easily because that's an information that is accessible to JavaScript code that does the data collection in your real user monitoring pipeline. But how on earth should you know whether people are logged in or what their account settings are like? You can't know that. And this is the problem. So basically the core challenge here when you're comparing CrUX data to RUM data is that Google implicitly applies some kind of sampling that is just a black box for you. And therefore, it can happen that you have a RUM report and a CrUX report and they just don't align. And that's totally fine because that's how it is. Deal with it. And we've written an article where you can read more details on this. But this is the gist. Yeah. Now you could say, well, what now? Like, what do I make of this? Yeah, maybe let's compare CrUX and RUM to get to some kind of conclusion here. The cool thing about both is they're based on field data. Yeah, and that's good because as opposed to lab data, field data reports mean they reflect actual performance. So they reflect the experience of actual users, and you have some kind of valid hint on how users find your website, because it's actual user data. But the rest is pretty different between CrUX and RUM. First, CrUX is super cool because it's open data, and Sebastian mentioned that already. It's zero effort for you to set up because it's already there. You just need to use it. And you also have data from your competitors. That's also super awesome because you can rank your own performance with your competitors' performance. What's not so cool is since it's basically a service that is provided to you and is already there, you have fixed granularity at different levels. So, for example, what Sebastian also mentioned is you have a fixed temporal granularity. You can only get monthly reports, or you can get the current performance, but as an aggregate of the last 4 weeks. So it takes quite some time until performance changes trickle into your CrUX report. Then you only have fixed dimensions, so you can't really define dimensions that are relevant for your specific use case. And you only have data from some Chrome users with this sampling that you can't really look through. RUM is basically a stark contrast because it's not public data. It's based on data that you have to collect in a custom deployment. And as I pointed out on the slides to show what backend does to collect data, it's quite complex to build a cool real user monitoring pipeline. It's complex to operate, and you only have data for your own website, so no competition ranking is possible. But, and that's the cool thing, you have complete freedom because you do everything yourself. You can, if you do it right, have real-time and full detail reporting on anything that is interesting for you regarding performance. You can use custom dimensions, and you have data from all browsers. And the bottom line here is basically that both are cool tools, but both don't really give you the full picture. So we think it's actually not the CrUX versus RUM sentiment that you should apply to yourself, but you should rather see this as a love story because you can just have RUM and then enhance that with CrUX, or use CrUX data and then say, okay, let's put some RUM on that. And on the rest of this talk, I'll just illustrate what I mean by that and what you can do and what backend does to give you the best of both worlds, basically. So what you see here is basically the rolling window that you see in a CrUX report. So a CrUX report could look something like that. And then you would say, okay, doesn't look that good. But this could be data from a website where we just rolled out SpeedKit. And if that was the case, you see the scatter plot at the top where the gray dots basically indicate performance of the website before SpeedKit was rolled out, and the blue dots, they indicate performance after the rollout. And if you had a traffic light for the performance of every day, which you don't, but if you had that, it might look something like this, and you would see, wow, on the right, that looks good. I want that, yes. But the overall report still looks kind of crappy because only 2 days are optimized and reflect the good performance, and the rest is just lame, and it takes until that trickles down to your report, because after 7 days, looks better. After 2 weeks, looks even better. And after 4 weeks, you get the full picture, because now the report reflects the entire entirety of the improvement. And the cool thing here is that the mathematics are not that magic. So you can basically do forecasting. And that's something that backend does. So when SpeedKit is rolled out, you can just track the performance. And after, say, a week, you can basically do a forecast to estimate where the performance might be when you are actually through with your 4 weeks. And that in turn means that you could compare your performance in a competition ranking based on what the estimate is for the performance after the rollout, when everything reflects SpeedKit performance. So this is one way that you can enhance CrUX basically without anything. Now, I want to give you some roadmap features to highlight interesting things that are in development at backend right now in this context. One thing is that I mentioned earlier, backend also collects obviously access logs and caching statistics in the CDN, which makes sense because CDNs are heavily in use in SpeedKit under the hood. And currently there is a dashboard in development that gives you all the high-level KPIs to give you a at a glance overview over your global user base, activity around the globe, caching efficiency and stuff like that. Then there's also a dashboard in development that basically looks a bit, again, a bit cruxy, but with potentially more metrics, because this is based on RUM, and also you can drill down and by all custom dimensions. So for example, you could check the real user monitoring data for all the web vitals, but for individual page types, and thereby identify things where you could see more improvement or where you are already good. And we think this is super helpful. And to help you find bottlenecks and analyze your performance, there are also two things in store, the Speed Guard and the Speed Advisor. And the Speed Guard basically monitors your real user monitoring data continuously and checks whether there are anomalies somewhere in your data. For example, when there's a new Firefox version and that just tanks performance-wise, then this might not be visible overall that much, but the Speed Advisor would indicate that there's a dimension like the browser equals Firefox group, which just performs significantly worse than usual, and then it would indicate a solution, or at least point you towards the problem. And a bit more general, without the incident-related fashion here, the Speed Advisor takes your website data, so real user and lab data, and then basically analyzes, the thing is, we have a best practice database based on the entire real user monitoring data from our significant traffic that we see. And based on this, we generate insights and also suggestions what best practices could be applied to your website, because we can correlate technical, say, artifacts with performance and behavior. Yeah, and if you think this sounds interesting, I'd like to mention, because otherwise people will be mad, that backend is actively seeking cool people to work on tech problems. So if this sounds awesome, then please visit the link that you see at the bottom, or drop me a line and I will connect you. And on this shameless plug, we'd like to end the talk. So yeah, thanks for your attention. And if you have any questions for us, we'd be ready to answer or dodge them now. Thanks.